Welcome to the bilingual e-lectures organized by Directorate of Technical Education for the benefit of diploma students. Why bilingual? Because most of our students comes from rural background, studying their subjects in school in Tamil medium and find very difficult to understand the subject because in higher studies most of the good textbooks are written in English. For them, this bilingual lecture will be helpful, more helpful. I am going to deal with linear integrated circuits in a series of lectures which comes in the 4th sem curriculum of Electronics and Communication Engineering branch. I plan to cover 5 units of the syllabus in this series of lecture. This is my first lecture. To start with, being a 4th semester students, you will be familiar with discrete electronic devices, passive devices, resistor, capacitor, inductors, and active devices, diode, transistor, and so on. Also you would be familiar with constructing discrete circuit using a discrete devices. All of you know this is a transistor, discrete device. Similarly, using active and passive devices, you know to construct the circuit in a breadboard or even in a PCB. Lab la breadboard la இந்த devices எல்லாம் connect பண்ணி circuit construct பண்ணி test பண்ணி பார்த்திருப்பீங்க. That is called discrete circuit, right? The same circuit later in your later semester you could fabricate in a PCB, discrete circuit. Then what is this? What is this? This is a IC, integrated circuit, most often familiar with the name IC, right? This is another IC. What is integrated circuit? Integrated circuit is a miniaturized low cost electronic circuit consisting of active and passive components fabricated together on a silicon substrate. What is IC? It is a miniaturized, that means size is very low. See, lab la ஒரு 10 சென்டிமீட்டர் ஏரியாக்குள்ளே நீங்கள் கன்ஸ்ட்ரக்ட் பண்ணுற ஒரு டிஸ்க்ரீட் சர்க்கியூட்டில் நீங்கள் மேக்ஸிமம் ஒரு 10-15 காம்பனண்ட் தான் வைக்க முடியும். வேரஸ் இந்த integrated circuit within a small area, 10 centimeter square area, even 1 centimeter square area kulla you could fabricate, you can integrate thousands of transistors, lakhs of transistors, even today's technology permits crores of transistors on a small area. That is the integrated circuit. So it is a miniaturized circuit, size is very low and low cost compared to the discrete circuit because the ICs are fabricated in batch processing. The cost is very low, and in this technology all the active and passive components you can create and connect it in the form of circuit and fabricate it. That is IC, right? Now you see, so this is what I have shown you. If I come to IC, students should not think that this entire part is not an IC. This is only a package, right? Package with external pins. But if you look at inside the package, you have your circuit here. This is what your integrated circuit within a small centimeter square area, and they are connected to the external pins. There is a provisions for connecting this integrated circuit to the external component you need a contacts, they are called the leg of the IC or IC pins. These pins are connected to this internal integrated circuit through the wires, wire bond. There are so many techniques to connect these pins to the internal circuit. One of the method is using the wires, wire bond, right. So, this is only a package, plastic package. So, this is what I see. Now, why we need integrated circuits? We are happy with discrete circuit. Suppose for example, I need a rectifier circuit. So, I know what are the components required. I assemble it in the breadboard or in a PCB and connect together using soldering iron. I got a circuit, discrete circuit. Then why I have to go for IC, integrated circuit? There are so many advantages. As I said earlier, நான் ஏற்கனவே சொன்ன மாதிரி size reduction, miniaturization means size reduction. முன்னாடிலாம் பார்த்தீங்கன்னா in 1960s ரேடியோலாம் வந்து வெரி பிக் இன் சைஸ், ரேடியோ சர்க்யூட், ஸ்மால் ரேடியோ சர்க்யூட் வெரி பிக்காக இருக்கும். கம்ப்யூட்டர், த ஃபஸ்ட் கம்ப்யூட்டர் ஆக்குபைஸ் அ ஃபுல் ரூம், ஒரு ரூம் ஃபுல்லாக கம்ப்யூட்டர் சர்க்யூட்ஸ் இருக்கும். பிகாஸ் the devices are size very large in size. But today we are able to fabricate the entire computing chip in a millimeter squared area. See our cell phone, we are able to keep it in our pocket, can do lot of functions. How does it is possible? Because miniaturization, IC technology, right. So, miniaturization is the one of the main advantage of integrated circuit, and when you miniaturize, the component density is increases. What is component density? The number of components, number of transistors per circuit. ஒரு சின்ன 1 millimeter square ஏரியாவில் 1 millimeter by 1 millimeter square ஏரியாவில் 10 காம்பனன்ட், 100, 1000, 10000 இப்படி இன்னைக்கு டுடே 1 crore of transistor would be fabricated. 1 crore டிரான்சிஸ்டரை வந்து 1 millimeter ஏரியாவுக்குள்ளே நம்மளால் வைக்க முடியும். The component density is very more. Today's technology permit it. So, this is one of the major advantage of IC. Next, batch processing result in cost reduction. What is batch processing? ICs are fabricated in a batch. For see, in a 10 centimeter dia silicon wafer, it is possible to create 8000 squares. Like this, each square is 1 millimeter by 1 millimeter, that is 1 millimeter square area. Like this, 8000 squares can be made on the 10 centimeter dia wafer, right. So, each square is a chip, one circuit. In a batch, around 80,000 chips can be fabricated, right. See, ஒரு பேட்சில் 10 வேஃபர் ப்ரிப்பேர் பண்ணுறாங்கன்னா ஒரு வேஃபரில் 8000 சிப்பு தயாரிக்கலாம். ஸோ 10 வேஃபரில் 80,000 சிப்பு தயாரிக்கலாம். But see, all the integrated circuit may not be perfect due to the imperfection in the manufacturing process. There may be a faulty IC, right. So, in the IC production terminology, it is called as yield. Number of good IC is yield, right. For example, say 20% is only yield, good ICs, yield is only 20%. Then let it will be a 16,000 IC, right. If 10 wafers are fabricated, that is 80,000 chips are fabricated, assume that only 20% is good, that means 16,000 ICs are in good condition, let other be fault. So, in a batch we are able to fabricate 16,000 ICs, so obviously the cost is very less. So, the batch processing result in cost reduction. So, when the size is less, obviously power consumption is less, right. Also the system reliability is improved. What is reliability? That is, in a discrete circuit we connect the component together using soldering iron. So, there is a possibility of disconnection between the component, then the circuit will not function, whereas in the IC the connection between the components is made through the metallization process, continuous metal deposition. So, there is no possibility of disconnection க்கு வாய்ப்பே இல்லை, because it is a metallization layer is on fabricated on the components wherever you need to connect. So, obviously the reliability is increased, right. So, no soldering iron joints, better functional performance. Of course, the compared to the discrete circuit, IC circuits performance is very good, also the operating speed is very high, right. Now we saw what is IC, right, and how, what is the advantage over the discrete IC. Now let us see what are the classification of IC, what are the different types of integrated circuits. So ICs are classified based on different criteria. Based on the function, the ICs are classified into linear IC and digital IC. What is linear IC? So in this linear integrated circuit, the output of the circuit is linearly proportional to the input of the circuit. That means when the input voltage increases, output proportionally output voltage increases, right. So the input and output may have any value of voltage, whereas in digital IC it is there are only two possible values on, that is 5 volt or 0 volt, 1 or 0. That is, on the device in the digital IC will operate either in on state or in off state, not in between the two. See, for example, you take a transistor படிச்சிருப்பீங்க தேர்ட் செமஸ்டரில், அதோடைய அவுட்புட் கேரக்டரிஸ்டிக்ஸில் 3 ரீஜன் இருக்குது, கட் ஆஃப் ரீஜன், சேச்சுரேஷன் ரீஜன், ஆக்டிவ் ரீஜன், ரைட். ஸோ இன் சீக்வன்ஸ் கட் ஆஃப் ரீஜன், active region, saturation region. Suppose if you want to use the transistor as a amplifier, that means you have to bias it in the linear mode, right. So you have to fix your operating point on the linear region, that is in between the cutoff and saturation. Then you can use your you can use the transistor as a linear device, whereas in the digital IC you have to bias the transistor in between cutoff and saturation, right. That is, transistor acts as a switch, it will switch from cutoff to saturation or saturation to cutoff. Cutoff means off, transistor is off, 0. When you bias when you operate the transistor in saturation region, that means 1, right. So off, on state. That is the difference between linear IC and digital IC. So linear IC is the operational example, one of the example is operational amplifier, that is the hero of our subject. We are going to discuss in detail about the operational amplifier in the coming series of lectures. Digital IC example is gates, AND gate, OR gate, NAND gate, NOR gate, XOR, XNOR, all you have studied in your curriculum. 7408 AND gate, 7404 NOT gate, 7432 OR gate, right. So these are the gate ICs, and flip flops and microprocessor, microcontroller, all are digital ICs, right. So, this is the classification based on the function. Based on the fabrication technique, that means how the IC is fabricated, how the IC was manufactured, right. Based on the fabrication technique, they are classified into monolithic IC and hybrid IC. What is monolithic IC? Monolithic is the word originated from Greek word. The word mono means single, mono refers to the single, litho refers to the stone, monolithic IC refers to the single stone or single crystal. Single crystal refers to single silicon chip as the semiconductor material on top of which all the active and passive components are interconnected. Okay. So, the idea is very simple. In monolithic IC you have a base material, semiconductor material, maybe a silicon, on which all your active components and passive components are going to be created, above which they are going to be connected through the metallization process and the circuit is formed. This is the idea of monolithic IC, right. Monolithic ICs are considered as best mode of manufacturing IC. It can be made identical. What is meant by identical? In a batch, suppose you are fabricating 10,000 IC, all the ICs are identical, means electrical characteristics are same, behave in a same way, perform the same function, right. So, identical. High reliability, of course, because devices, connections, everything is done on a fabrication process itself, you do not do anything externally. So, the internal circuit is highly reliable, it is packed also. So, it is manufactured in bulk in very less time. Bulk manufacturing refers to the batch processing, right, low cost. Monolithic IC compared to the hybrid IC, it is very low cost, but there are some disadvantages with monolithic IC, limitations. They are meant for low power ICs, that is low power rating. For low power applications only monolithic IC technology is suitable. It cannot be used for high power applications as it can't have power rating of more than 1 watt, right. So, the circuit consumes less than 1 watt. For the circuit only this fabrication technology is suitable, right. High power applications you have to go for hybrid IC. Components such as another important disadvantage with monolithic IC technology is you cannot fabricate inductor. Inductor cannot be fabricated using this technology. Why? What is the inductor? Inductor is the coil, right. Normally we use using a copper, we made it as a coil form, that is inductor. That cannot be fabricated in monolithic IC technology. The passive components within the IC will have another important disadvantage with monolithic IC is you can create the passive components, resistance, capacitors, everything, but very low values only. If you need a very high value of resistance and capacitor, you have to connect it externally, right. So, the external connection is required from the IC pins to obtain high values. So, these are the some of the limitations with monolithic IC, but this is the better mode of manufacturing technology rather than the hybrid IC, right. There are another technologies, thin and thick film IC. It is little bit different from monolithic technology. What is thin film and thick film IC? See, basically these two, thick film and thin film IC technology, the circuits fabricated using this technology are larger than monolithic IC and smaller than discrete circuits. So, it stands in between two, right. Why do we go for IC integrated circuit? Because miniaturization, small in size compared to the discrete circuit. And in the thick and thin film, when you go for thick and thin film IC, it is not that much miniaturized compared to the monolithic technology. So, in between, right. It can be used in high power applications one of the advantage compared to the monolithic. So, if you want to construct the circuit for high power application, you can prefer the thin and thick film IC technology. But one of the important disadvantage with this technology is you can fabricate only the passive components, resistors and capacitors, but diodes and transistors and all you cannot. It cannot be integrated with diodes and transistors. Diodes and transistors can be externally connected to its corresponding pins. Resistors and capacitors can be very well fabricated using this technology. That is one of the limitation. Now, let us see what is thin film IC. It is fabricated by depositing thin film of semiconducting material on the surface of substrate. That is the idea, right. So, for example, suppose you want to fabricate a resistor, right. So, on the base material, that is substrate, it is called substrate. On the substrate material, semiconductor material in the form of thin film is deposited in a rectangular structure. By controlling the depth and the width of the rectangular structure, we are able to fabricate different value of resistances. What is resistance? R equal to rho into L by A. What is L? Length of the resistance. What is A? Area, cross sectional area of the resistance, right. So, obviously by varying either L or A, you can control the value of resistance, right. So, in the film, depth or width or length, by varying you will be able to fabricate different value of resistance using the thin film technology, right. By controlling the thickness and the width of the film, we can fabricate resistors of different values. Similarly, capacitors. What is capacitor? Two conductor in between insulator, right. So, two conducting material and between the two you should have insulation material, that is capacitor, right. So, on the substrate deposit a conducting film above which insulation material and then again another conducting film. So, you get capacitor, right. So, by depositing two conducting films separated by an insulating layer, you could fabricate capacitors. Different value of capacitance would be obtained by varying the thickness of the conduction film or the distance between the two conducting film, right, or the width of the insulation layer, right. So, this way you could fabricate different value of capacitors in thin film technology. What about inductor? Is it possible to fabricate inductor using thin film technology? Yes. On a substrate, film material is taken in the form of film and it is laid on the material in the spiral form, right, similar to the coil. That way you could fabricate thin film inductors. So, here you can see the diagram of a thin film technology. Yeah, it is a thin film, thickness is very less in terms of microns, and see this is the base material, right, and here you can see the capacitor. So, this is one conducting film and in between there is a insulation material and so on. Here you can see the resistor, right. By controlling the width, by reducing or increasing this width, you could fabricate different value of resistances, right. So, here you can see the image of the thin film. Then what is thick film IC? It is commonly called as printed film circuits. Screen printing, நமக்குலாம் தெரியும் screen printing னா என்ன, எப்படி வந்து invitation print பண்றாங்க, same technology. Screen printing is a technique used to obtain the desired circuit pattern on a ceramic substrate, right. So, paper print எப்படி பண்றோம், paper அது மேலே வந்து desired pattern அது மேலே ink force பண்ணோம்னா we get the desired pattern on the paper. Same way, same technique is adopted here. Screen printing is the technique used to obtain the desired circuit pattern on a ceramic substrate, right? How the desired circuit pattern is obtained on the ceramic substrate? எப்படி? Here inks are used for printing the circuits. Ink consists of materials that have resistive, dielectric or conductive properties, right? So whatever the type of ink you want, that you could select, and there is a screen. You have to prepare the screen. How to prepare the screen? It is woven by stainless steel material and framed by aluminum, right? So it's simply mesh, stainless steel mesh framed by the aluminum material, that is screen, on which what is the pattern of the circuit you want to create on the substrate. என்ன பேட்டர்னை நம்ம கிரியேட் பண்ணணுமோ, சர்க்கியூட்டை கிரியேட் பண்ணணுமோ, அந்த சர்க்கியூட்டோட பேட்டர்னை ஸ்க்ரீனில் ரெடி பண்ணிவிட்டு அது மேலே இங்கை ஃபோர்ஸ் பண்ணுறோம், ரைட்? இங்க் கன்சிஸ்ட் ஆஃப், ரைட், the screens are actually made of fine stainless steel wire mesh. The films are fused to the substrate after printing by placing them in a hot high temperature furnaces, right? So that is the thick film technology. Finally you got a pattern on the substrate in the form of thick film, right? So it is something like this. So you have a substrate here and thick film deposited through the screen printing technology. Here you have a resistor, capacitor and so on. இது வரைக்கும் நம்ம என்ன பார்த்துருக்கோம் அப்படின்னா, ஐசினா என்ன, ஐசிக்கும் டிஸ்க்ரீட் சர்க்யூட்டுக்கும் என்ன டிஃபரன்ஸ், வாட் ஆர் த கிளாசிஃபிகேஷன் ஆஃப் ஐசி. ஸோ we have seen two major classification in terms of function, linear IC and digital IC, in terms of fabrication, monolithic IC and hybrid, and also we have discussed on thin film technology and thick film technology, right? Still we are going to see the other classification of IC in the coming lecture. Thank you.